Welcome to Utilizing AI, the podcast for machine learning, deep learning, and other artificial intelligence topics. Each episode brings experts in enterprise infrastructure together to discuss applications of AI in today's data center. Today, we're discussing the challenges of building scalable storage systems to support AI applications. First, let's meet our guest, James Coomer from DDN.
Hello, yes, I'm James Coomer. I'm Senior Vice President of Products at DDN. So go to ddn.com and you'll find the website for our company. We've been around for over 20 years, building storage and data management solutions for really tough data challenges. So when the capacities get big, when the performance challenges are very large, then DDN is the company which our customers come to.
I am Andy Thurai, founder and principal at thefieldcto.com. You can find me on Twitter at Andy Thurai and on LinkedIn. You can also check us out at thefieldcto.com where we do a lot of emerging tech consulting work, AI, ML, and the cloud.
And I'm Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT. You can find me right here every week on Utilizing AI. I also am organizing the AI Field Day event, which is coming up soon. And you can connect with me on Twitter at @sfoskett. So James, I'm very familiar with DDN, having been in the enterprise storage space myself for quite a while. And I know that DDN has tackled some really challenging high volume and high capacity, high performance storage for the media and entertainment space in the past. I was not at all surprised to see as well that y'all are working to support AI applications. So maybe we can just start there with just a little bit of a foundation of, what are the challenges of supporting these kind of applications that require, tremendous amounts of data, tremendous amounts of throughput, lots and lots of clients with simultaneous access. These are not conventional storage applications.
Yeah, that's right. So we have indeed been exposed to the real full breadth of tough data challenges, whether that's in high performance computing or media, streaming videos, etc. But AI is a bit different. I mean, firstly, there's not just one thing that represents AI data workflow. It's, of course, a big pipeline, and it all starts with data coming in the first place. And that data might be coming in from vehicles, recording with cameras, LiDAR, radar. Might be coming in from satellites, might be coming in from life sciences instruments, sequencing machines, etc. So that ingest phase is part one. Then there's a data labeling phase. Then there's, of course, the all-important deep learning phase, where we're teaching our models and training our models based on these big data sets. Then when we move into production, we're performing inference, a whole different class of I/O challenges right there. And then that data moves on, typically not really to be archived, but to be reused and go back into these model retraining events. And so we have this sort of endpoint, which isn't a traditional archive, but is a very, very active archive. So the data volumes get very large, but we still want to access them very, very regularly. So that shape is genuinely different from anything else we've seen. And DDN's been really working on our technologies and our services in order to support customers with these large data volumes from which they want to extract value at big scales.
Okay, so you talked about a few areas in there where the AI has a data problem. We're producing a lot of data, but also getting the data ready for AI is a problem, from the data collection to data labeling to categorization, all of this. I want to deep dive into all of that. But we were talking a little bit about the fact that, one of the largest some of the largest autonomous car vendors are using you, without naming names. But people don't realize when you have a live car going in, not just the instrument data, but the camera and the whole video and everything that comes in a matter of hours, when you do it for days, and when you store it and try to make meaning out of it, and trying to inference from that, you're talking about terabytes of data. So scaling enterprise production AIs to scale to terabytes of data or even petabytes of data is not easy. Is that a common problem that you see with that? And how are some of the guys solving this?
Yeah, you're right. This is really problem number one, the most basic problem we try to solve. So as you say, in fact, in this autonomous driving world, these vehicles come back from a drive around the city with between 1 and 200 terabytes of data each. And there's many vehicles and there's many cities. So it easily turns into hundreds of petabytes. And that's a challenge because, particularly in AI, you don't want to siloize your data. You don't want to end up with 100 silos of 50 terabytes each or 50 silos of a petabyte each. Really, you want to have a very large, scalable, centralized data storage, which is robust, etc. And that's really where DDN comes in. So apart from the performance and all the other features, managing big data volumes is what we've architected the systems for. And the way we do it is by scaling the storage infrastructure in a very different way from any other storage system. And this is a general principle, really. It's called parallel file systems. And in general, we can look at traditional NFS file systems, which companies, organizations might use for NAS and maybe even to serve virtualization environments. And they have a scaling property which really doesn't help them stretch to tens of petabytes beyond. So the way we get around that is by adding a bit of intelligence into the network and into the compute systems. So to scale big, we need to scale the problem to include all those elements which are also scaling, the compute scaling, the network scaling bigger. And by having an intelligent client on the other end of the network, we can really help systems scale really limitlessly. And we do support some of the biggest supercomputers, AI supercomputers in the world. So, and just to dig into that a little bit, the reason that helps is now this intelligent client is sharing the problem of scale. It's able to direct I/O, direct the data and read the data from where it lies. And compare that to traditional NFS, there's no intelligence there. It has to go to something and then something else has to proxy for that. So in traditional NFS, you get this sort of big back-end data movement, which is ultimately not scalable because you're trying to squeeze all that scaling problem into the back-end infrastructure. By having an intelligent client, we're kind of sharing the problem out a little bit, and it allows us to scale by compute, scale by network, and scale by storage. And that's what really helps us have these systems which are 100 petabytes plus.
First of all, there are 20 areas in there I want to double click, but let's start out with the obvious one first. You talked about collecting 20, 30 terabytes of data per car, per city. So some of them are already mapped out, meaning that that the cars or the autonomous vehicles are able to inference based on what's being fed to them. But the actual problem will come because video is a thick load. Not only a thick load, but also it's unstructured load. People don't realize that, right? So it's hard to make meaning out of that. When you're getting terabytes of data, which is unmapped, for example, if the car is driving in a territory or terrain, which is not already in that, how do you inference that? But more importantly, how do you take that volume of data and update your model that you feed it back into all the other autonomous vehicles that are coming into that area or in general overall map? That's a major problem, isn't it?
It is, and it's a very complex process that our customers have been developing over the past few years. So you're right, 100 terabytes of video and LiDAR and radar data can come out of a vehicle after a trip around a city. And they do keep going around the same city many times because you need to see the city in different weather environments. You need to see these rare events. You want them to happen because you want to capture those rare events. And what happens, of course, for some of these scenarios, there's somebody in the car and they're labeling things live. So they'll be going around in the vehicle. They'll be labeling stuff saying, I've seen a cat. There's a signpost which says stop, and they'll be adding some labels as they go around to add some supervision to this process. So the data comes in pre-labeled, but then has to go through a big process to add more labels. The critical thing in autonomous driving, in fact, in all of AI, is having trust in this AI. And what that really translates to is knowing the complete set of data of objects that you've put through your deep learning program. So if you've seen once a stop sign with snow on the top, you want to be able to label that. I've seen a stop sign with snow on the top and get that into your model. So this huge problem is, this huge challenge is complex, and the data feeds in, yes, every day from each vehicle, but it goes round in a big cycle. So they have re-simulation, and they have virtual simulation where they have virtual environments, and they have these virtual cars driving around virtual environments, adding more and more data. So in fact, while it seems a big data problem, by its nature, deep learning loves data. It just wants more and more. And so it's more of a, for our customers, it's more of a challenge of working out where the unique objects are to make sure that the mass of objects, even the unique rare events, is pushed back into that model. It is a big challenge.
So this has been a perennial challenge in the storage space. And I think that many people outside of the storage industry might not understand that storage clients, storage endpoints are really not intelligent at all. And that always has held back the development of storage. So whether it's a conventional file server or SMB or NFS, or even cloud storage systems, for the most part, the client has a very limited dialect, a very limited range of interaction, and basically just treats the storage system as a, something else, hey, something else, store this data for me, rather than being actively involved in data placement and data labeling and data classification and data movement and all that. So what you were just describing, James, makes it sound as though not only is your client actively participating in sort of where to put the data and how to get the data there, but also actively participating in sort of categorizing data. Did I hear that wrong?
Well, we're assisting that process basically by relieving the infrastructure of undue load. So but you mentioned a bunch of things, and we talked a bit about how an intelligent client and a client with a bit more intelligence than an NFS client can help scaling. But also, of course, what it can do is it can protect data from corruption over the network. We've got the data from the application. We can make sure it's arriving at the storage safe just as you sent it. We can help performance because we're not handing off the problem to an NFS protocol. We're actively engaged in moving data over the network. And in fact, our intelligent client, and in general, these intelligent clients can have a virtual networking layer to optimize the data movement through the network as well. So the fun thing is, by having this intelligent client, we're not just giving you fast storage, we're helping you make the most of the network layer, because we're really using RDMA protocols or fast protocols across that network. We're helping you use your compute and apply labeling and compute intensive challenges, because our intelligent client is offloading the work, the network load from the compute system. So we basically, not only do we help storage with our intelligent client, we really help the whole infrastructure. And in fact, the biggest benefit for customers is that these intelligent clients make the applications go faster, which is something people really often don't really measure. They'll think about a storage system and think, well, I want this storage system because it says it's going to do 10 gigabytes a second or 1 million IOPS or something like this. And of course, as we all know, the critical thing is how much faster is your application going to go? And often the application isn't actually held up by the backend storage system itself. The storage system is wonderfully powerful, but it's everything in between the storage and the application that is not allowing that potential to get through. So by spreading this storage loveliness right to the application, we can track the data, we can accelerate the data all the way into the application. So where we really think the intelligent clients are important is accelerating workflows. And we really mean that. We mean because we're interfacing directly with the application. We're not handing it off to NFS and handing it off to a network protocol. We're interfacing directly so we can push the data right into where it's needed. And with AI, like we're talking about here, the optimizations we've put in to cope with TensorFlow, to cope with PyTorch, to cope with the sort of behaviors they have, we can put in those fixes, those improvements, not just at the storage layer, but the network layer and the client layer as well. So we can kind of fix the whole data path end to end into the application and out again.
So there are a couple of areas in there I want to double click. But first of all, I love the concept of, how should I put that? Feeding dumb data to intelligent processes, right? Because most of the intelligent applications and processes are held back by, not, as you said, it's not a dumb data, it's a smart, well, data is data, there's no smart or dumb data. But how to make meaning out of and get the right data in place, right? So that's the problem. So did I hear you say that, regardless of the framework, whether it's a PyTorch, TensorFlow, doesn't matter what it is, on the fly, you'd be able to figure out what data is needed when, and then you're able to assemble the data on the fly using AI and then provide them?
Yeah, so you open up a couple more avenues to discuss here. One is a data platform in general really needs to be flexible. You know, these companies are investing a lot of money in the data itself, in the data scientists, in the AI processes, and the last thing they want to happen is for suddenly to find a roadblock in their storage system. So flexibility, protocol support is important, and you know, we put in optimizations for individual AI frameworks. So you're right, TensorFlow, PyTorch, we run these in our labs and make sure we can cope with the sorts of IO. So just an example, some of these applications like to use mmap as their primary POSIX call. That can be particularly troublesome to some storage infrastructures. So we've optimized the mmap call. Even though it sounds like a minute detail, it can have a huge impact on how the performance of these AI frameworks. And then you mentioned about, you know, finding the right data. Typically, you know, the user decides the data set they're going to train on. So just like the autonomous driving or in life science or in finance, you want to basically choose the data set so your model is holistically trained across the correct span of elements that you want to train upon. What we do, so they already know that, we don't have to help that problem. But what we can do is we can look in this very large scalable storage system, and in the background, with kind of intelligent algorithms, you can find the data that tends to be hot. You can find some tendencies and optimize that data in the right place for quick access. So that means, you know, you might have flash, you might have HDDs, and of course, when we're talking about tens, hundreds of petabytes, HDD is still, you know, king when it comes to price per terabyte. But we can sit there in the background, we can juggle this data around and optimize the hot data into flash at very, very large scales. The sort of thing that's easy to do in a tiny system for enterprise, but very, very difficult to do when the system's containing massive amounts of unstructured data. So yeah, so we do all that stuff. So we do have to have flexibility and support SMB, NFS, S3, as well as our intelligent client. And then in the background, we also do kind of clever things to try and optimize the data placement. So it's on flash, ready for some reads or whatever.
So then let me ask you a follow-up question on that. The problem domain that you described, that's actually a major problem with most of these enterprises, particularly with the model creation phase, right? Because they have this probably unlabeled, undocumented, unstructured dark data, tons of it spread all over the place because not necessarily all of them are centralized storage. It's a massive issue. But isn't particularly when it comes to HPC, right? Because they need to assemble all of that to, you know, things like medical imaging, autonomous driving, combination thereof. But isn't that the same problem that some of the data lakes are trying to solve? How are you unique, and what is your differentiation?
So the intelligent client is part of that. And the other part is we're POSIX. So what we found is data lakes, which has traditionally, well, the past 10 years meant big data, which is also implied Hadoop. The challenges there is it's quite a particular storage infrastructure. It was built for batch workloads, and you know, it's not POSIX. It's its own special thing. And what we're finding is, well, firstly, AI frameworks go massively fastest when using POSIX. It's an extremely, I mean, people think of it as a complex protocol, but actually it's super fast. So the fastest way of accessing your data is through POSIX, especially with an intelligent client, such as the one that DDN provides. So Hadoop's kind of out the window now. It's Spark, it's TensorFlow, it's PyTorch. Everything's maximally in memory, and they're all using POSIX for the fastest access. But not exclusively. So other protocols are still important. So we can still interact with the legacies of batch workloads because we're POSIX, absolutely standard, and we can export and allow people to access our data through NFS, S3, and SMB. So that flexibility is key, flexibility at decent speed, but the best performance is no question through POSIX, accelerated by these intelligent clients.
And I'll just jump in here as the resident storage nerd. So when he says POSIX, what he's referring to is a set of IEEE standards that dictate how computers should interact with other systems. And so essentially, when you hear that a system is POSIX compliant, what they're saying is that the system uses standard accesses for various various components, including storage. And so it's not some weird proprietary thing. They're engaging with the operating system, with standard operating systems like Unix and Windows in a standard way.
Yes, thanks. So the stuff on your laptop is POSIX file system. The stuff in our global parallel file systems is a POSIX file system, the same standards, which basically mean the data is correct when you read it and correct when you write it, and there's a certain format. That's all built in.
So let me pull you back. You guys are going too deep for me, all technical details. So let me pull you back a little bit, level up, and ask you a question about particularly with the, look, at the end of the day, major problem AI has is, a data problem, whether it's a data collection, data storage, data labeling, providing the right data, all kinds of issues. But so if they were to use a solution similar to yours, I mean, there are a ton of areas that you touched on. You almost seem to cover every problematic angle of AI, data problem of AI, that is. How does it help companies when I'm creating a model, instead of spending 3 days, I'll do it in half hour? Or what's my advantage? Why do I care? Why do I use you?
Yeah, very, very good question. So the first one, of course, is time to market. So when companies have invested so much, they want to build a system that's going to scale and start quickly and then scale pretty easily. The starting quickly thing is resolved by companies such as ours, who work very closely with the vendors who are creating the GPU infrastructure. So we've been working closely with NVIDIA, very tight integrations. We've got multiple reference architecture publications. Our systems are plugged into NVIDIA's largest supercomputer. So huge amounts of testing and qualification go in there. We define the compute, the GPU systems, the DGX systems, as they call them. We define the network. We define the storage. So customers can really pick a solution off the shelf, starting small, starting literally this large, and scaling to largest supercomputers in the world. They can pick that and see the performance they can expect to get from that from a white paper. Not because we've made it all up, because we've really tested it in these huge labs. So that's advantage number one. It's time to market with a solution that's going to ultimately scale. Now, you mentioned, so why else would customers sort of come to DDN or come to a company like DDN? I guess the other thing is we do specialize just in storage and data management. So that specialization is always important to our customers, because whenever they're deploying, let's say there's so much risk involved around the whole space of developing a new AI strategy, and issues always happen. There's always funny things happen in the network. Applications behave strangely for whatever reason. There's bugs. Having expertise which really knows networks, really knows compute, really knows storage, that's important. And one of the reasons DDN is quite good at this is because we do span the network. We work in the compute, we work in network. So the problem doesn't stop at our storage. The problem really encompasses the whole environment. So any organization which will partner with these customers with these big strategies with high risks would do well to find a storage partner who's got that expertise, not only just in storage, but in network and compute, because it's all super connected. And optimizing really means optimizing everything, not just optimizing storage. And finally, the shift is moving in. So these various questionnaires by various analysts basically ask CIOs where the biggest challenges are in AI. And 3-4 years ago, it was actually in finding data scientists was number one, and number 2 and number 3. It really is shifting now as people are starting to implement. They're realizing infrastructure is actually a big issue at scale. And it was always there, but now it's really come to the fore. It's security, it's scale, it's performance. And there's 2 pieces there. One is people are starting to understand that in order to develop an AI strategy, not only do you want to cover everything in your plan, but you want to have overhead. You want to be able to build a space where your data scientists can really innovate. Because it might be those people who actually, find the golden egg from the golden goose and make your company really be amazingly competitive. So you need to have a system that's not only capable, but also more than capable. You want to be able to have those data scientists have a lot of freedom to innovate. And to de-risk that whole environment by having expertise being used to dealing with these very, very tough data challenges. So all that comes together, and I think companies are in a difficult position given the biggest risks and the huge potential rewards, and so they need to think: is traditional storage going to work today and in the future? And what kind of services and surrounding portfolio and people do I need around that solution to help them succeed much, much longer term? Because one thing they've all got in common, these customers, is they don't quite know what's going to be truly successful on day one. There's always going to be surprises on that route, so you need to keep flexible.
I think another thing that a lot of companies are faced with is a lot of conflicting information and kind of almost FUD in the marketplace about what do you really need in terms of storage and so on to support AI applications. And certainly we've heard people say, oh, AI applications, they need to be all flash, for example. There's no way you can build AI applications using disk. It has to be all flash in order to support the performance requirements. Or we'll hear somebody say, oh, well, it has to be a distributed solution where the storage lives on the clients instead of in a centralized server. Or it has to be object, or it has to be NFS, or it has to be have some proprietary interface. There is a lot of confusion over there, and a lot of companies out there selling basically what they've got on the truck instead of what the true answer is. So, I mean, how do you answer that, considering that essentially you're selling a pre-existing system, not one that was specifically designed for AI? What makes this system better than others?
Well, it's a very good question. And the answer is that we actually have almost everything you mentioned. We do that. So we can provide storage that resides in compute. We provide S3 object stores. We provide HDD and all flash. So we've got relatively little bias when it comes to this area. When we're talking to our customers, we've really got a very broad solution portfolio that does everything at scale. So the way, and so given that, it's never totally objective, but reasonably objective starting point, we've got a broad range of solutions. What do we say? Well, we do say, of course, flash is best, but there's economics just come into play. And when our customers have 100 petabytes of storage, there's really, it's going to be another, well, according to Gartner, is 2030 before even the lowest cost flash kind of gets into its dollars capacity competitiveness against HDD. Is still quite a way off, which is why we built these hybrid solutions that really scale. So of course we love to sell flash to customers. All NVMe is great, but when there's just literally an economic boundary there, then we can at least give them the best for HDD for their money. So we can also handle that so they mainly see flash performance, but mainly pay for cost-effective capacity, which is, of course, the ideal place in there. In terms of objects, we can talk to our customers about the benefits of S3 object protocols for a long time. We've been using that for over 15 years. Where it comes into play in AI is really for ingest. You've got these dumb systems out there, maybe they're satellites, maybe they're CCTV cameras or whatever. They want to push things into your network through S3. It's a very handy protocol when your devices are scattered around and they're relatively dumb. So bring stuff in through S3, that's great, but there's no way you can perform with S3. You can't do your inference with S3. The protocol is inherently slow compared to POSIX. So that's that argument. The argument about putting all your data inside the compute, it's always got to come out. Unfortunately, it's always got to come out at some point. And so you really just add complexity more and more by really mainlining on that route. It's all right to have an element of caching, if you like, in the compute, but by mainlining on, I'm going to put my storage in my compute is, an endless disaster because the data's got to come out at some point, and the manageability of data on storage devices inside compute is not very good compared to managing data in proper storage systems. So we do cover all these elements. We have thought about them a lot while we're architecting our systems for AI, which is really why we've come around to the system we ship today, which we think is the best of all those worlds.
Well, thank you so much for that. And unfortunately, we do kind of have to wrap up here. But before we do that, I'd like to move on to the lightning round of bonus questions here at the end, which is always a lot of fun. So warning to the audience, James has not been given a heads up about which questions I'm going to ask him, and we'll see what he comes up with here as an answer for some of these. And of course, it's all in fun. So here you go. Let's kick things off. Number one, would you say that machine learning, deep learning, and artificial intelligence are synonymous, or do those terms mean very different things?
They mean different things. AI is the big wide picture. Deep learning is the particular sort of machine learning which benefits from large data volumes.
All right, next question. DDN has a long history in the video space, storing video and processing video. When will we have ML that's video focused and that operates the same way that Siri or Alexa works with audio?
Well, kind of now, I suppose. A lot of our customers are doing real-time video inferencing. Some really fun ones, actually. So in fact, there was a recent announcement in London. I live in the UK, there's an announcement in London about a new store which changes the shopping experience. And we've had 3 customers do this over the past 3 years. Very interesting companies. So they have the cameras in the shops, in the supermarket, and they don't look at you. They're not looking at your face and recognizing your face. That would be bad. They're looking at what you put in your bag. So they're seeing the cucumber, they're seeing the tin of beans, and they're tracking it all. And when you walk out the shop, it says, hey, your phone goes ping, and it says, would you like to pay for this now? And you go, yes, and you pay for your cucumber and your tin of beans without having to go through a checkout. So lovely example of real-time video streaming, which hopefully means that all those people who work in supermarkets can spend their time helping you find the cucumbers and beans rather than stalling you at your checkout experience. So that's one of many, and there's lots of these rather nice video streaming inference examples, often used in film work when you might be videoing outside and you want to, in real time, blur out some advertising which you didn't want to display in your live stream and broadcast to millions of TV viewers. And again, we'll have got these inference capabilities which are going to blur out these adverts as you pan your camera around the city center, so you don't accidentally advertise for somebody else. Lots of great examples. In fact, it's probably the most fun, the fun world is the video inference world.
I knew that you'd have something to say about that. Again, this is you guys are a big gorilla in that market. So cool. And then following on to that, you mentioned supermarket workers. Are there any jobs, maybe not supermarket workers, but are there any jobs generally that are going to be completely eliminated by AI, jobs that will no longer exist in 5 years?
5 years? Oh, damn it. Are you going to give me 10? So I think the most likely candidates, well, firstly, as some elements of factory work, Industry 4.0 is there's some things people are doing today which kind of really doesn't make sense on these manufacturing lines. So that's a big area for improvement and optimization. And the whole COVID thing has only accelerated that. The need not to have people unnecessarily sitting together in factory environments is an important area for improvement for manufacturing. And then ultimately, self-driving cars, they're a big one. It's not really 5 years, to be honest, but we'll start to see point solutions. For example, when those lorries come into the huge logistics park to pick up their parcels, as soon as they come through the gates, then they can hands off and the truck can drive itself into the right place, park itself in the right place according to the computer algorithm, according to the logistics system, without the drivers messing things up. So there'll be point solutions in vehicles outside of the commercial, the open road, where we can put AI in charge to improve the process.
You almost stole a fourth one of our questions, because we do have a question about autonomous driving that we ask a lot as well. And your answer was definitely in line with what we've heard from others on that question. So in fact, I would say that overall, we've heard pretty much consensus on a lot of these and some differing opinions on some others. But thank you so much for joining us, James. It's been great to talk with you and learn a little bit more about how you and how DDN are working in this new world of AI and ML. Can you let us know, where can people connect with you if they'd like to continue this discussion and follow your thoughts?
Yeah, so go to ddn.com, take a look at the blog there. Myself and my colleagues often put out our blogs there. You can email me at jcoomer@ddn.com, JCOOMER@ddn.com. And if you want to hear from me, and 3 of my colleagues will all be presenting at GTC. That's the NVIDIA conference on AI starting 12th of April. And we have 4 presentations going on there.
How about you, Andy? What have you been up to lately?
Doing a bunch of work on the AI stuff, as you might have seen. Just published an observability report, which is an extended AI ops kind of thing for GigOhm, and doing a lot of work in that space. So you could check out most of my work at thefieldcto.com. As always, you can follow me on Twitter at AndyThorai, or connect with me on LinkedIn, or find most of my work at thefieldcto.com.
And as for me, you can find me on Twitter at sfoskett. You can also find me every week on Wednesdays for the Gestalt IT News Rundown, posted to gestaltit.com. And of course, every Tuesday here on Utilizing AI. So thank you for listening to the Utilizing AI podcast. If you enjoyed this discussion, please do subscribe, rate, and review, since that helps our visibility. And please do share this show with your friends and share it on social media. This podcast is brought to you by gestaltit.com, your home for IT coverage across the enterprise, and thefieldcto.com. For show notes and more episodes, go to utilizing-ai.com or find us on Twitter at utilizing_AI. Thanks for listening, and we'll see you next week.